11.2 chi-squared test for homogeneity. Last time we did the chi-squared test of goodness of fit, and that was when we had one categorical variable for just one population or treatment. Now the difference is this one is we still have one categorical variable, but two or more populations. So the question that this test answers is the hypothesized distribution of still one categorical variable the same for two or more populations, two or more, so that's the difference, two or more populations, and you might be populations slash treatment. So in an example we'll do with depression, it won't be different populations, there'll be different treatments. So St. John's wort, Zoloft, or a placebo. So populations treatment for two or more populations treatment. And so what you'll typically see is that you'll see your data in a two-way table. So when we did the M&Ms, there was just one population, which was the M&Ms from the main, wherever they're made, and we were looking at the distribution of color. That was our categorical variable, color, and there were several different colors possible that you could represent just in a single row. But here, since we have two or more populations, you're going to usually see a two-way table. And so the only thing interesting to note here that's different from the previous notes we took is that the expected count is just a little bit different for coming up with that. You have to do it for each cell, expected count for any cell and of your two-way table. And the formula for that is row total times column total, row total, and I'll show you why in the example, but this is basically what you're doing. Row total times column total divided by the table total. And so you have to do that for every cell. It's a little more time consuming. So that's how you come up with your expected count, and your degrees of freedom then is different too, because you're looking at a two-way table. You can't just do the number of categories minus one like last time. You would do it, it would be the number of rows minus one times the number of columns minus one. Columns minus one. And that's how you come up with your degrees of freedom to put in your calculator. And because we're on the notes for 11.2, I'm gonna just do the description of the last test in this chapter, even though we're not doing the examples for it yet, just so that all the notes are done. So the last test, and it's better for comparison, I think, if it's here. So chi-squared test for association independence. That'll be the last thing you'll see in this chapter. Association or independence. It's chi-squared test for association independence. And when do you use this test? That's you're asking the question in one we're back to one population or treatment. In one population, is there a relationship between two different categorical variables, like a cause-effect type of relationship or association? So in just one population, is there a relationship slash association between two different categorical variables, which we haven't done yet. Two different categorical variables. And you'll see that in the last extra example. We'll do one of those, but you won't deal with that today at all, just so that it's there in your notes.